All right, hey guys, here's our last video that we're going to do today. Um, all right, so we just finished up with momentum of a system, and now the last whoa, that's funny. I don't want to use the highlighter. I want to use the pen. There you go. So the last section we're going to do is what he called conservation of momentum. Conservation of momentum. Momentum. Yeah, I spelled that right. Okay, so conservation of momentum. So here's what this says. You can write along with me here. I'm going to use my little zoom tool. All right, so conservation of momentum says that the total momentum of a system before a collision is equal to the total momentum. That's not going to work. Let's erase that. The total momentum of the system after the collision. So hopefully this kind of makes sense because we saw this happen in yesterday's lab. We saw that when we added together our pre-collision momentums, we'd get a number, and then we'd run the simulation, and then afterwards we would see, sorry, I'm going to rewrite this word right here because that's bad. So we'd see that after we ran the simulation, we let the two objects hit each other, the total momentum was still the same once we added it up. So all that happens is momentum gets transferred from one object to another object. So one object's going to lose some momentum, the other object's going to gain some momentum. And then they end up equaling out. And so we have a really simple equation for this. So the equation is going to say the momentum P of the system before is going to be equal to, and actually, hang on, I'm sorry. I know you guys probably wrote that down. Let's do this. Let's do system BC, before collision, is going to be equal to the momentum of the system after the collision. Okay, so the momentum of the system before the collision is equal to the momentum of the system after the collision. All right, there we go. That's all the notes that we need for today. We're going to move on and play a fun game next.